All right, guys, we're going to go ahead and get started with graphing quadratic functions in standard form now, okay? So the other day we did vertex form. Today we're doing standard form. Make sure you know the difference. So we're going to review the vertex form of a quadratic function first. The vertex form was y equals a parentheses x minus h squared plus k, where the vertex of this is h k. Okay, so now we're going to move on to standard form of quadratic function, which you see our standard form here. Y equals ax squared plus bx plus c. You've seen that before. We've talked about how a, b, and c are just constant numbers. But some things you need to know about this when talking about graphing. A is your reflection and or dilation. And C value is your y-intercept, so where it crosses the y-axis. Key characteristics of graphs in this form. Vertex is going to be, you have to find x and y individually. So x is negative b divided by 2a. So you would plug in your a and b value and solve for x there. Once you solve for x, you need to substitute x into the equation to find your y value. So substitute in x value after you've solved for it. Axis of symmetry is the same thing here. X equals negative b divided by 2a. The y-intercept is our c value. Domain is also negative infinity to positive infinity. Okay, so for range here, if a is less than 0, it opens down. That means it's from negative infinity to the y value of the vertex. With the bracket. If a is greater than 0, it opens up. And now it's just the other way, y value of the vertex. To infinity, parentheses, okay? All right, let's look at the procedure for graphing functions in this form. Step 1, identify the x value of the vertex. Step 2, make a table with the x value of the vertex at the top. Then choose either two values for x that are less than the vertex or two values for x that are greater than the vertex. Step 3, use the equation to find y values. Step 4, plot the points from your table, draw the axis of symmetry, and then reflection to find two or more points and draw a smooth curve. Okay, so now we're going to try that. Example 1, we're going to graph the function of y equals x squared plus 2x plus 4. Standard form, letting us know that our a value is 1, 2 is our b value, and 4 is our c value, okay? So let's find the x value of our vertex. So x equals, remember, negative b divided by 2a. We're going to plug those in. So x equals negative, our b value is 2, divided by 2a, our a value is 1. 2 times 1 is 2, so negative 2 divided by 2 is going to give us negative 1. So if x equals negative 1, we need to take that negative 1 and plug it in for x here so we can solve for the y value. So I'm going to go ahead and do that. So y equals negative 1 squared plus 2 times negative 1 plus 4. Negative 1 times negative 1 is 1. 2 times negative 1 is negative 2 plus 4. So y is going to equal 3. Okay, so let's go ahead and do our table now. X, y. We're going to plug that in. Okay, so our vertex point is negative 1, 3. Now we need to find two values greater than negative 1, so we'll just use 0 and 1, and we'll go ahead and plug those in to find what our y values are here. So y equals 0 squared plus 2 times 0 plus 4. So 0 squared is 0, 2 times 0 is 0, so y equals 4. And then I'm going to do plugging in x equals 1, so 1 squared plus 2 times 1 plus 4. 1 squared is 1, plus 2 times 1, which is 2, plus 4. So 1 plus 2 is 3. 3 plus 4 is 7. So let's go ahead and plot those points. Plot our vertex first. So negative 1, 3. We know that this is going to open up because our x squared is positive. Going to plot our point 0, 4. Remember, it's a reflection there. And then we're going to plot our point 1, 7. Reflection. So your axis of symmetry is here at x equals negative 1. Okay, we're gonna draw our smooth curve. Okay, and that's all you have to do right now for graphing. All right, moving on to example 2, graph the function, identify the vertex, the axis of symmetry, whether it's a maximum, what the maximum minimum value is, and the domain and range of y equals 2x squared minus 4x plus 5. So let's start out with finding the vertex. So x equals negative b divided by 2a. You can label it. So 2 is a, negative 4 is b, 5 is c. So negative b is b is negative 4. 2 times a is 2. Negative 4, negative and negative gives me a positive 4. 2 times 2 is 4. So 4 divided by 4 equals 1. You can go ahead and plug that in to find your vertex if you'd like. So y equals 2 times 1 squared minus 4x plus 5. 1 squared is 1 times 2 is 2. Oh, I didn't plug in my x there, which is 1. Negative 4 times 1, which is negative 4 plus 5. So y is going to equal 2 minus 4 gives me negative 2 plus 5 gives me a positive 3. So our vertex is 1, 3, which means my axis of symmetry is x equals 1. Okay, so let's go ahead and point that. 1, 3. Axis of symmetry here. It is going to open up because our 2x squared is positive. Let's go ahead and make our table now. So start with the point 1, 3, our vertex, and we're going to pick 2 points. Let's do less than that. So let's go 0, negative 1. Okay. So if I'm going to plug in 0, y equals 2 times 0 squared minus 4 times 0 plus 5. 0 squared is 0 times 2 is 0. Negative 4 times 0 is 0. So y is going to equal 5. So we can go ahead and plot that point. 0, 5. Do the reflection of it. Okay, now we're going to do our x equals negative 1, so y equals 2 times negative 1 squared minus 4 times negative 1 plus 5. Negative 1 squared, so negative 1 times negative 1 gives me a positive 1 minus 4 times negative 1, which is going to give me a positive 4. So negative 4 times negative 1 gives me a positive 4 plus 1. 2 times 1 gives me 2, so 2 plus 4 plus 5, so that will give me 11. Okay, it's going to go up a little bit higher then. We'll just put it up here, put the other one over here, and draw our smooth curve to where the graph is continuing. Make sure you're hitting those dots unlike me. All right, we have our vertex, we have our axis of symmetry. Now we need to decide if it's a minimum or a maximum. So at our vertex, because it's going up, this is going to be a minimum of the vertex point, which is 1, 3. The domain is always negative infinity to infinity when dealing with parabolas. Range is going to be our y value of our vertex, so 3, because it's opening up. We're starting with the y value of the vertex, so 3 to positive infinity. And that is all you have to do for example 2. Okay, moving on to example 3. Identify the vertex, axis symmetry, the max and min value, and the domain and range of the y value. So let's do our vertex first, starting with x equals negative b divided by 2a, where our a is negative 1. Don't forget about the sign in front. B is negative 2, and c is 3. So plugging in our negative b, which is negative 2, 2 times our negative a, which is negative 1. Negative and negative here will give me a positive 2. 2 times a negative 1 gives me a negative 2. 2 divided by negative 2 is going to give me negative 1. So our x value in our vertex is negative 1. Now I need to take that and plug it into the equation to solve for our y value. So y equals negative parentheses negative 1 squared minus 2 parentheses negative 1 plus 3. Negative 1 times negative 1, so negative 1 squared is a positive 1, but I still have the negative in front, so it's still going to be a negative 1. Negative 2 times negative 1 gives me a positive 2, and then carry down the plus 3. So y is going to equal negative 2, or negative 1 plus 2 plus 3 to give me 4. So our vertex point is negative 1, 4. Okay, now our axis of symmetry is x equals negative 1. Is it a minimum or a maximum? I know that I'm going to have a maximum because it is a negative here. So when it's our a value is negative, it opens down like this. So our maximum point is going to be right there. Now moving on to domain and range. So domain we know is negative infinity to infinity. Our range is our y value, and depending if our a value is less than or greater than 0, our a value is less than 0, so it opens down, which means we're going to start with negative infinity and go to our y value in our vertex, which is 4 bracket. That is what you need to be able to determine. Okay, moving on to example 4. Tell whether the function opens up or down and explain how you know. So this all depends on our a value in the equation. So in this equation, y equals negative 3x squared plus 2x minus 4. What is our a value? Our a value is negative 3. So if a equals negative 3, that means that it's going to go down, okay? It's negative, so it's going down, looks like an N. So we know it goes down. And how do we know that? Well, we know that because A is negative. Okay. If you have any questions with graphing in standard form of quadratic equations, make sure you're jumping on those Google Meets to ask those questions. If not, have a great day.